Hello friends, in the previous video we have seen the problem on internal hinge. Now in this video we will see how to draw loading diagram if shear force diagram will be given to you. Now see the given problem. The shear force diagram of simply supported beam as shown in figure. Draw loading diagram and bending moment diagram of the beam. See, you can draw the bending moment diagram by using loading diagram, but the important task is to draw shear force by using shear force diagram to draw loading diagram. You can see this given diagram. This is SFD, that is shear force diagram. At point A, it is first 0 and 164 kilonewton. A to C, there is no any force, so line is straight. You can see at point C, the points are 164 and 84. In between C to D, straight line is given, so there is no any force in between C to D. But at point D, you can see 84 and this value is 24 kilonewton. So from D to F, there is no any force, so line will be straight. So at point F, the answer is 24 kilonewton. C, that is 24 kilonewton. But from F to B, you can see inclined line is there. So uniformly distributed load is in between F to B. At point G, you can see this point, that is point G. The distance is 0.6 meter. At point B, that is 176 and 0. See how you can convert the given SFD into loading diagram. Draw this diagram very carefully. After that, draw the dotted lines from vertical dotted lines at every point, at A, at C, at D, at F, G, and B. Draw the vertical lines and C, come at point A. Here I am showing you both things. At the time SFD as well as loading diagram. Once you will get the loading diagram, you can draw the bending moment diagram. In that video, I will not explain you the bending moment diagram because already we completed that part in the previous videos. Now the important thing, how we can convert SFD into loading. See, at point A, first of all, draw one horizontal line, that is baseline, and then you can start. See, from A to this, that is positive sign, so upward, it is 164 kilonewton. You can see sudden rise at point A indicates upward reaction at A. So reaction RA, that is 164 kilonewton. So at point A, there will be a vertical reaction, that is 164. From A to C, the line is straight. So you have to draw straight line. No variation till C. So no variation in shear force between C to D. You can see sudden drop at point C indicates downward load. See, at point C, there is a sudden drop. So 164 minus 84, you will get 80 Newton. So that is a drop of 80 kilonewton. You can see here at point C, there is load 80 kilonewton. From C to D, there is no any force. So you have to draw till D straight line, that is baseline. But at point D, you can see there is a sudden drop. So 84 minus 24, answer is 60 kilonewton. So 60 kilonewton is acting vertically downward. You can see here that it's sudden drop. Now the next, and that is very important, from F to B, the inclined line is given. So inclined line, so there will be a, from F to B, there will be a UDL, that is uniformly distributed load. So how we can calculate intensity of UDL, that is dV by dx. See, this one is minus 176. So minus 176. Here you can see 24. So minus 24 upon 5. Answer is minus 40 kilonewton per meter. So minus indicates it's a vertically downward. So 40 kilonewton per meter, that is the intensity of UDL from F to B. Here, see the answer, 20 kilonewton per meter, that is UDL. And now at point B, you can see the vertical rise. So at point B, the reaction will be 176 kilonewton. This is the loading diagram. See, in the previous case, we seen first loading diagram, then SFD, and then BMD. In this diagram, SFD is given. You have to convert that diagram into loading diagram. So very simple, by using basics of shear force diagram and bending moment diagram and loading diagram, you can draw, you can convert SFD into loading, loading into SFD. You can draw by using loading diagram to SFD, or you can say by using SFD, you can draw loading diagram. After getting the loading diagram, you can calculate the value of bending moment diagram. You can draw the bending moment diagram also. Till this problem, I have completed different problems related to the SFD and BMD. You can see here, by using this loading diagram, you can calculate bending moment diagram also. Here you can see from F to B, there will be a parabolic curve. A to C, there is no force. C to D, there is no force. D to F, there is no force. So line will be inclined. You can see this is the inclined line in the BMD. At point A and at point B, the bending moment will be 0. Just you have to calculate at C, D, F, and at point G. Already you know how to calculate bending moment. By using sagging and hogging concept, you can calculate bending moment. Thank you. Thank you very much.